Okay, Assalamualaikum and good day to all my students. Okay, so this is the last subchapter for the chapter 3. The title of this subchapter is Hardenability. Okay, so let's get started to our learning video. Okay, so the learning outcomes of this subchapter is learning outcomes are you have to differentiate the concept of hardness and hardenability. So these two kinds of term of hardness and term of hardenability is different. Okay, and then you also have to develop the hardenability, or that test we call it the Germany and quench test. Okay, and the first slide shows the definition of hardenability here. Okay, what is the hardenability? By definition, it is a measure of the depth to which the metal of an alloy may be hardened by the formation of martensite as a result of a given heat treatment. So in simple words, the hardenability is just a measurement, okay, of how an alloy can be increase their hardness by using the heat treatment. Okay, so we know that if the contain the martensite, so the material will be increase their hardness. Okay, so once again, the hardenability is a measurement, okay, to which of an alloy may be hardened by the formation of martensite as a result of a given heat treatment. Okay, so the hardening process, example of the hardening process, as example is quenching process. Okay, for steel consists of heating and rapid cooling to form the martensite. Okay, if you saw a medieval Hollywood movie, okay, of how they forging a sword, like the King Arthur, okay, have a great sword. So how they forge their sword is by heating the alloy, the steel, and then it rapidly cool in the water, right? So that's kind of the quenching process is similar, but in the modern way, we have a more sophisticated and a more accurate process to form the steel with high hardness. Okay, so the cooling rate depends on the medium used for the quenching. Okay, so the cooling rate is depending on the medium used for the quenching. As example, if the water give a faster cooling rate than oil and more than air cooling. Okay, so generally the faster steel cools, the harder it will be. And then the Germany test is used to measure the hardenability of a steel. Okay, so this is a diagram of how a Germany test works. Okay, so this is the quench ends. This is one end of the two end. The other end here is here, right? Okay, so one end only is quenched by the water or any other cooling medium. So in this case, it writes down that this H2O, so this is the water. So after it is heated, then it is rapidly cooled down here, so the martensite will form around here. And then when there are martensite, so the alloy here have higher hardness. Okay, so the hardest part here is where it meets the water. Okay, and then by far more than the quench end here, so the hardness will decrease. Okay, and this is what the how Gemini test works. Okay. Okay, let's see our video here. You can see from the YouTube. I just share you for the YouTube. Okay, cannot play. Okay, let's open in the YouTube, right? Okay. Okay, so this is the sample that they want to test the job to using the Gemini test. It's just a rod, a steel rod here. First, it is heat treated to 1550 Fahrenheit, degree Fahrenheit. Okay, after it is heated, right, and all right. Okay, now you pay attention. Okay, this is where it is quench. Quench is where you put the rapid cooling. In this case, it used the water to one end only. So in this case, only the rod end here is quench, and the other rod end here it is left. Okay. Okay, you see that this is the water, so it starts to form the bottom side. Okay, from right around here it is red. The steel in red color means it is very hot, and then after it is quenched here, it starts to rapid cooling and to form metal side. So that's why it will increase its hardness here around here. And then it will measure the hardness measurement lah, using the hardness tester here. So like I said earlier, where the point of the quench end, it will be the highest hardness, and the point there is the far from the quench end, so it is the least hardness in that rod lah. Okay. Okay, so this is similar to that test. This end is quenched with the water, and then after they using the rod well hardness test, and then the point here will be the hardest, and the hardness from the quench point here will decrease along with the distance from the end quench end here. Okay, so from that test they will form a hardenability curve. Okay, what is hardenability curve? Hardenability curve is the graph showing the effects of the cooling rate on the hardness of S quench steel. Okay, so we know that the more value of Germany distance, so it decrease the hardness. So from this diagram shows more Germany distance, less martensite, so become sulfur. Okay, less hardness, more soft. Okay, so the cooling rate at the quench end is very fast, but becomes slower as the distance from the quench end increase. Yes, as we saw in that video, once the rod reach the water, it forms instantly the martensite, right? And then it gradually form to the another end. But okay, let's see here. Okay, you see, right? Okay, right now here, around here, it instantly form the martensite, so it's very hard point here, and then it start. Yes. Okay, and finally it start to become slower, right? Maybe it stop around here, and then the other region here that is not formed from the rapid cooling, it will become soft region. Okay, so this is where the martensite form, where the rapid cooling occurs, and then the other around here, it become soft. Okay, the hardness is lesser than the around the region here. Okay, so therefore the distance from the quench end is an equivalent measure of the cooling rate, and can be used to give the hardenability of the steel. Okay, so this is the example of the hardenability curve. Okay, time from 0.1 to 1 to 10 to 200 and 1000 seconds. So this is the axis of this graph for the time is in the form of the log of 10. Okay, so this is 10 minus 1, 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, and 10 to the power of 3. And then the y-axis here is in the showing that the temperature of the material itself. Okay, so when let's say here, when it starts at around 700 degrees C, and then by the time it will reduce to a certain point, it stop cooling. Okay, so from here we know the point here is the hardest one, and then the end point here is the soft one. Okay, the softest one. Okay, the most least hardness. Okay, so at quench and steel cool most rapidly, therefore it contains most martensite. Yes, around here it starts cooling rapidly, and then cooling rate decrease with distance from the quench ends. Okay, with the distance from the quench ends here, this is what we call the quench ends. Okay, where it is reach the water, it touch the water. So with the increase of the distance, the greater carbon diffusion and give more pure light, bainite, and lower hardness. So around here, because it lesser martensite, has lesser martensite, but more pure light and bainite, so the hardness will decrease, is reduced. So uh, the other example, this one is the hardenability curve for 5 type of steel. Okay, and then so what is the importance of this curve, hardenability curve? Yes, it is very important for the engineers to control the properties or to design the properties that they want. Okay, let's say they want the hardness, high hardness, so they will control the quenching process. Maybe it can control the cooling rate to get the desired hardness of the material. Okay, so this is the points where the hardness differs to the hardenability. Yes. Okay, of course we know that hardenability is the ability to the measurement to be hardened by treatment and quench, heat treatment and quench. Okay, so heat treatment is also including the rapid the quenching, right? Quenching process. Okay, so the hardness here is the also the measurement, but it measures the resistance of the material to penetration or plastic deformation or scratching. Okay, hardness here apa yang kita tahu adalah kekerasan lah kan. Keras, berapa keras dia. Okay, but hardenability is measurement kita banyak lagi ke dia boleh jadi keras dengan kita gunakan heat treatment. Tu beza lah. Okay, hardness test here measure the resistance of a material to penetration by a sharp object. Hardenability test measure the hardenability of steel by heat treatment process, which shows the effect of cooling rate on steel hardness. Beza kan? Hardenability ni fokus kepada heat treatment, macam mana nak tambah kekerasan dia. Hardness test ni untuk tengok kekerasan, nilai kekerasan bahan tu lah, daripada dia menjadi berubah bentuk. Okay, so you can try by your own the definition. What is the difference between the hardness and hardenability? And the name of testing, yes, this is what we call the name of testing here, hardness test, and this hardenability test. Okay, sketch. I don't. Okay. Oh, what is the sketch here? Okay, so this is the sketch. It was I know, right? Okay, this is the sketch of the diagram of the Germany and sequence test, and this is the diagram of the Brinell, Vickers, Knoop, and Rockwell hardness test. So in that video that we saw earlier, it used the Rockwell hardness test. So bear in mind, it's not the only Rockwell test. For it may be use the other hardness tests such as the Brinell, Vickers, and Knoop. And then this is our exercise. You have to do by your own self, okay? And then you compare your answers with these answers. So I just put it a few seconds. You can pause this video to compare your answers with the scheme answers here, answer scheme here. Okay. And then that's it. So good luck for the chapter 3. And by finishing this subchapter 3.3, it also means that we have completed our chapter 3. So be prepared. Please do the tutorial for the chapter 3, 6 and 7, 7 and 8, and then be prepared to have the quiz. Okay, so maybe next week or 2 weeks from now we are gonna have the quiz for the chapter 3. Okay, so until the next video, thank you, good luck. Okay, take care of yourself, and assalamualaikum and bye bye.